Hello and welcome to this video lecture presentation on angles and similar shapes. So a right angle is when a vertical line and a horizontal line meet and you end up getting a 90-degree angle that results from it. A straight angle comes from a straight line and is this angle from here to here. This adds up to 180 degrees. Basically, it could be comprised of two right angles. Next is acute angle. An acute angle will measure between 0 degrees and 90 degrees. And then we have obtuse, and that measures between 90 degrees and 180 degrees. So an obtuse angle would be something like this, where it's beyond 90, and then acute angle would be something like this, where it's under 90. Okay, we already talked about perpendicular lines. That's when a vertical line and a horizontal line meet to give you a 90-degree angle. Parallel lines are two lines that run along each other but never touch. So if you were to graph parallel lines, they would have the same slope. So now let's take a look very quick at supplemental and complementary angles. Alright, so complementary angles, excuse me, are two angles that add to 90 degrees. So if I had one angle that's 36 degrees, the complement of that would be 54. If I had a 19-degree angle, the complement of that would be 71 degrees. Now let's move on to supplementary angles. Supplementary angles are two angles that add to 180 degrees. So an example is if I have a 30-degree angle, the supplemental angle to this would be 150. Now let's look at adjacent and vertical angles. Alright, so if we're at the same vertex, we're in the standard X position, and if we create two angles from the same point, from the same starting point, these are called adjacent angles. These would be called adjacent angles. And then if I have something like this, horizontal line, an angle line, this angle here and this angle here is called a vertical angle, and vertical angles equal each other. So if I call this angle 1 and angle 2, because they're vertical angles, angle 1 will be equal to angle 2. Now let's take a look at segments of transversals. This is very analogous to similar triangles or similar sides where you could use ratio and proportions to set it up in order to get the missing side. Alright, so here's an example. So what we're going to do is we're going to bounce back and forth from one similar side to the next, because notice here, yeah, basically one shape, here's your second shape. So we're going to bounce back and forth. I'm going to say, I'm going to use the word as I use the word as, I'm jumping over to the other shape and looking at the similar side. And then when I say is to, then I'm going to go back to the first shape that I worked with. Now it doesn't matter where we start. We could start with this side or this side. It's irrelevant. We'll try this. So 6.5 is 2. So what's the similar side as 6.5? X. As, so now we're going back, 5.65 is 2. What's a similar shape to that? 7.75. So now we could cross multiply. 6.5 times 7.75 is equal to 5.65 times x. If you divide by 5.65 on each side, that will give me about 8.92. So that's what this similar side is. And that is how you work out a problem just like that. We'll do one more. So this is 3.2, 3.05, 4.75, A, B, this is 6.25, this is D, this is 5.05, and this is C. Alright, so why don't we start off with finding A first, because we'll use these two values here in this shape, and then we'll use that. Okay, so it doesn't matter where we start off. You can start off with the 3.05. You can say 3.05 is to A, is 3.2 is to 4.75. We can start up top. Really doesn't matter. I'll start off with the 3.2. So 3.20 is to 4.75 as, now you go back, 3.05 is to A. Now you could cross multiply. So A times 3.2 is 3.2A. It's equal to 3.05 times 4.75. So now we'll multiply this out. And we'll get about 4.53. So A is equal to 4.53. So now I can move on to C. I could use these ratios here. So let's take a look. So we have 3.05 is to 4.53 as C is to 5.05. We'll cross multiply again. C times 4.53 is 4.53C is equal to 3.05 times 5.05. That's equal to we'll divide that by 4.53 and we'll get 3.40. So C is 3.40. Now I could find B. I got these three dimensions that I could use now. So our C is 4.53. So now we can use these three dimensions. 4.75 is to 6.25 as 4.53 is to B. So now we could cross multiply again, and we get 4.75b is equal to 4.53 times 6.25. So that gives us 28.3 divided by 4.75. Now you get 5.96. So I get 5.96. Now I could use these three dimensions. So 4.53 is to 5.96 as 5.05 is to D. So if you cross multiply, you get 4.53D. Cross multiplying that, D times that. And then 5.05 times 5.96 will give you 30.098 divided by 4.53. And you should get 6.64. And that is basically how you walk through problems like this with similar sides. You could also do this with similar triangles. If you have triangles that have the same angle but different lengths, you do the same exact thing. So if you had something like this, so you could say 5 is to 8 as x is to 10, and then it would be the same thing, cross multiply, you get 50 is equal to 8x, divide by 8, and so on. So that will wrap up our discussion on angles and similar shapes and similar triangles. Thank you for watching and listening, and have a good one. Bye-bye.